Chapter 11, probability, the chances of something happening. So up here on the board, I have like one of our main little formulas for probability. The probability of an event happening is the number of successful outcomes, what you're wanting, over the total number of outcomes. So if I have 12 pencils and pens in a bag, 7 are pencils, 5 are pens. What are my chances of pulling out a pen? Are y'all listening?
Can you repeat the question?
I had 12 pencils in a bag, 12 things in a bag. 12 are pencils, 7 are pens. No. See, you made me messed up. There's 12 items in a bag.
Yes.
7 are pencils, 5 are pens. What are my chances of pulling out a pen?
5 out of 12.
5 out of 12. That's probability. That's what we're talking about today. So hopefully this should be pretty easy. Probability of a simple event, one thing happening, okay? So what we're looking at to begin with is just being able to identify the number of successful outcomes, okay? So it's going to give us situations. Remember, I told you up here, the problems start on page 501. It looks like it's a whole lot because it's so many pages, but if you look at them, it's because they're word problems giving you situations. So this is, they're longer problems, but they're still just got simple answers, even though it looks big, okay?
All right.
Says Hernando is choosing a random number between the numbers 0 and 9. State the number of successful outcomes for choosing an even number. So he's choosing a number from 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? Those are the numbers he can pick from, right?
Yeah.
You don't have to list them out if you don't want to. You just got to know that's what they are. I wrote them out so you can see them. Some of you have to see it to know what I'm talking about. And then it wants to know the chance of him getting an even number. How many of these are even?
1, 2, 3, 4.
How many are even?
5.
5, right?
0 is even?
Well, even just means it can be divided by 2. Can I take 0 divided by 2? Because I'll still get 0, but I can still do it. So 5 even numbers. That's your possibilities. That's all you have to do. You read the situation, you identify how many of the successful outcomes you could have based on what it was asking for. Okay? What are you?
Sorry, that was my wallet.
Why do we have to see that?
Because it's custom made, Miss Pelham.
Okay. Number 2. It says Lisa is choosing a random number between 1 and 20. State the number of successful outcomes for choosing a prime number. So first of all, we need to know what prime numbers are, right?
Yeah.
Prime numbers, remember, only have 2 factors, 1 in the number. Is 1 a prime number?
No.
No, because it only has 1 factor. Is 2 a prime number?
Yes.
Yes, because it's 1 and 2. So 2 is a prime number. What's another prime number?
4.
No.
No, wait.
3
3.
is a prime number. Is 4 prime?
No,
4
no.
is not prime because
4
you
is
can multiply
composite.
2 and 2 to get 4 as well. You multiply 1 and 4 or 2 and 2. So 4 is not prime. Is 5 prime?
Yes.
Yeah. Are there any other even numbers that are going to be prime?
No.
No, because they're all divisible by 2. So we skip the even numbers. We're just focusing on the odds. Is 7 prime?
Yes.
Yes. 9?
Yeah.
Huh?
No.
No, because 3 goes into it. 11?
Yeah.
13?
Yeah.
15?
No.
No, because 3 and 5 go into it. 17?
Yeah.
19?
Yeah.
Okay, so how many primes are there? 1, 2, 3, 4, 5, 6, 7,
8.
8 prime numbers. Because it said from 0 to 20, so that's why I stopped at 19. Okay, so pretty easy. Find the different possibilities.
Yes, ma'am. Yes, ma'am.
Okay. So number 5. So you got to flip the page. On number 5, it says a deck of flashcards contains 4 of each number, 1 through 9. So that means there's 4 number 1s, 4 number 2s, 4 number 3s, 4 number 4s, etc. State the number of successful outcomes for drawing an even card at random. Okay, now if we think about what we did on number 1, how many even numbers do we have from 0 to 9?
Well, it says from 1 to 9.
Well, what? Oh, it says from 1 to 9. Okay, so how many even numbers do we have from 1 to 9?
4.
4, right? 2, 4, 6, and 8. So there's 4 of them, but then how many sets of cards are there?
4.
4. So for number, what is that?
3. 5.
5. You take 4 times 4.
16.
And so there's 16
Mm-hmm.
even cards. Because you have 4 even cards in each set. And there are 4 sets, so 4 times 4 is 16. Easy? Okay. Yes, it is. Y'all are supposed to agree with me faster. All right. Now, the next thing it talks about is relative frequency. Relative frequency assumes that all outcomes are equally likely. So the way we determine the probability is to divide the number of successful outcomes by the number of total possible outcomes. Okay, so our relative frequency is basically using that formula that I put up there on the top of the board above number 1. Okay, now when it says relative frequency, that means they're usually going to write these probabilities in decimal form. So you're not going to leave it as a fraction, you're going to write it as a decimal. So for number 9, it said Gerald hit the fairway 243 times out of the 312 times he hit off the tee. I don't know why I said ice, I can't see. Okay, what is the probability of Gerald hitting the fairway off the tee? So how many times did he hit it?
243.
Okay, so probability of hitting the fairway was 243 out of 312 times. So the number of times he hit it was 243. The number of times he tried total was 312. So you divide that, 243, helps if I turn it on, 243 divided by 312. It gives you can reduce the fraction. Okay, you can reduce the fraction if you want, and you get that. Or I told you when they're talking about it this way with relative frequency, they usually put it as a what?
Percentage.
A decimal.
Decimal.
Decimal. So you hit the little SD button if you're using the scientific calculator, and you get a big long decimal. We are going to round these, it said, to 3 decimal places. That's what it says in the directions. So you've got 0.77884, so it's going to be 0.779.
779.
0.779. Okay?
That's pretty good.
Yeah. So, number 10. Number 10 says, Baxter was able to hit the bullseye 616 times out of 883 attempts. What's the probability that Baxter will hit the bullseye? So probability of hitting a bullseye is how many times did he get it?
You got it 616 times.
Out of
883.
So the number of times that he was successfully hit it goes on the top. The number of times he tried total goes on the bottom. You divide.
And it doesn't reduce.
And you get a decimal. And you round to 3 decimal places, so be careful rounding.
Yeah, 0.698.
Okay. You getting that? Yes, no? Okay, we're on page 502. We just did number 9 and 10. So we got one more in this section. Okay, number 13. Number 13. It says a basketball player made 204 free throws of the 261 he attempted. What is the probability that he will make a free throw? So the probability of getting a free throw is he made 204 out of 261 attempts. So you take 204 over 261. Round to 3 decimal places.
Yeah, 0.782.
Okay, so is probability pretty easy?
Yeah.
Okay. So the first 3 problems that we did were just wanting us to find out how many of the successful outcomes there were. The second 3 problems that we just did was actually finding what they call the relative frequency or the probability, where you take the number of successful divided by the total number and you get it as a decimal. Now, the next 3 problems that we're doing talk about state whether each group of probabilities is valid. So for probabilities to be valid, we had some basic rules for probabilities that were at the top of page 498. So just flip back a couple of pages.
I don't like rules.
Up at the top of page 498, there's some basic rules for probability. It shows that the probabilities all have to be between 0 and 1. Okay? So our probabilities all have to be between 0 and 1. Okay? Probability also, if I add all of them up in a group, they have to add to equal 1. So like if I had 3 yellow marbles, 5 blue marbles, and 2 green marbles, okay? That's 10 marbles total. So whenever I add their fractions of getting a probability of red, probability of getting green, probability of getting blue, it has to add up to 10 out of 10 or 1.
Okay, that's smart.
And then the complement of some of the event is found by subtracting the probability of the event occurring from 1. But the main 2 things about it being valid are they have to be between 0 and 1, and the sum of all the probabilities must add up to equal 1. So those are what we're using for 15, 16, and 19.
19.
Okay? So for number 15.
15.
Okay, for number 15, it says you've got 0.2, 0.6, and 0.1. So are all of those between 0 and 1?
Yep.
Yes, they're all between 0 and 1 because they're all a fraction of a whole. Okay, they're all part of a whole. So they're all between 0 and 1. Do they add to equal 1?
No.
If I add this and this and this, I get 0.9. I don't get 1. So they are
not valid.
valid. And I'm going to put sum doesn't equal 1, so you know why they're not valid. Their sum did not equal 1, that's why they're not valid.
Yes, ma'am.
All right. Number 16. The numbers that it gave you were negative 0.3, 0.7, 0.6. So, is this one going to be valid, yes or no?
No,
Why?
because of the negative.
Because it's a negative. If I add them together, they equal 1. But this is a negative, and you can't have a negative probability. It has to be between 0 and 1. So you say not valid. And you put because it's got the negative. That's why it's not valid. Okay, then the last one in this section is number 19. Number 19 gives us the numbers 0.5, 0.1, 0.2, 0.05, 0.05, 0.1. It gave us a lot of numbers. Okay, are all of them between 0 and 1?
Yes.
Yes, they're all between 0 and 1. Do they add to equal 1?
Yeah.
He says yes, because this is 0.5. I'm just adding the decimal places. So 5, 6, 7, 8, 9, and then these two halves would make a whole 0.1, so 10. So then this one is
Valid.
that. Okay? So that's that part. Pretty easy?
Yes, ma'am.
Now, the next part deals with that last rule that I kind of read through real quick on the top of page 498. And that was about the complement. It said the complement of some event is found by subtracting the probability of the event occurring from 1. Okay? So like if, remember earlier I had 7 pencils and 5 pens in the bag. Okay? So if I want to know, if I know the probability of a pen was getting 5 out of 12, to find the probability of getting a pencil, I could take 1 minus 5/12 and get the probability of finding a pencil. Okay, so to find the complement, we're going to be subtracting the probability that we have from 1. So that's what we're doing on these. We're rolling over. Okay.
Number 21.
Still need to see that a little bit. I'll leave that where you can kind of see. All right. So we're on number 21.
21.
Okay. On 21,
21.
that the probability of A was equal to 0.02.
0.02. Yes.
So the complement of A. Now, this is my regular A, so my complement, they usually put the little mark on there.
Apostrophe.
Okay? It's like a little prime little hash mark thing. Okay?
Apostrophe.
All right, so this is for the complement of A. I take 1 minus A's probability. And so what's my answer going to be?
0.98.
And that's all you do on these, okay? You take 1 minus the probability that they have. Number 22, it gives you that the probability of A is equal to 0.312. So to find my complement, probability of the complement, I take 1 minus 0.312.
That equals 0.688.
Okay? Pretty easy? All right.
Yep.
Yeah. Next two aren't going to be quite as easy because we don't have the probability of the actual event first. So we have to find it and then subtract it from 1. Okay? So it says a certain area has 78 rainy days and 20 snowy days in a given leap year, which has 366 days. Which we're in a leap year, but it seems like it's lasting forever. Okay. If the event is the probability that it will be raining or snowing in that area, what is the complement? So how many days were rainy and snowy? You have
It was rainy and snowy.
plus 20, so you have what?
98.
You have 98 rainy, snowy days. Okay? Everybody agree with that? 98 rainy, snowy days. So
Yes.
if my probability is that it's going to be a rainy or snowy day. So the probability of rainy or snowy is 98 out of
366.
366.
98 divided by 360. Okay, I totally messed that up. It equals point.
Wait, what?
268.
Okay. So the
Let's go.
probability that it's not rainy or snowy, because that would be your complement, the opposite complements the opposite. So the probability that's not rainy or snowy would be found by 1 minus 0.268. So how many days are not rainy or snowy? What's that probability?
0.732.
Okay, so that's our complement. Okay, so we had to find the probability of the actual event first and then subtract it from 1 on these. Okay, so we're going to do the same thing on number 24. Okay, on number 24, it says, in the history of a given school, 3,002 out of the 12,444 graduates graduated with honors. It is, if the event is the probability that a student would graduate with honors, so the event is probability of graduating with honors, what is the complement? Okay, so graduating with honors is how many kids?
3,002 out of
12,000.
12,444.
444?
Yeah.
Is that right? Get fraction, change it to a decimal, round to the nearest place, to the nearest hundredth, no, 1,000th. Yeah, 1,000th place. Anybody agree with that? Yes or no?
Yes.
Okay. So that's the probability that a student that you pick out of all of them graduate with honors. Okay. Now I want the probability that they did not graduate with honors. Okay. So probability of them not graduating with honors would be 1 minus the 0.241.
And that equals 0.759. Decimal 759.
Okay. So we've already finished the problems from page 501 and 502, right? Everybody's getting all those down?
Yes.
So we're ready to look at the next page.
Page 503.
Now, the next part, you'll notice they don't have any teal ones in this next section because you still have to do that same thing down here too. So we're not doing that. We're just doing the teal ones. But it talks about mutually exclusive and not mutually exclusive. So if you had actually read through here in section 11.1, mutually exclusive means the probability of the one event has no impact on the probability of the other. The one can happen, the other one can happen, okay? They have no impact, no relation, okay? If that one happens, then the second one can't happen. They're two totally different types of probabilities, okay? One has no impact on the other. If this one happens, the other one can't happen. You can't have both at the same time. So like if I said my probability of getting a pencil or a pen out of the bag, if I get a pencil, can it also be a pen?
No.
No. So since the one happened, the other one can't happen. That's mutually exclusive. Not mutually exclusive would mean that they both could still overlap in some way. So like, let's say all of them were in there were the same color. So like they were all blue. So my probability of getting a pencil or a blue writing utensil, could it be a pencil and be blue?
Yes.
Yes. So then that's not mutually exclusive because it can be both of them at the same time. So that's what we're looking at on these, is trying to figure out whether they have, whether one means it can't be the other or whether they could both happen at the same time. Okay, so it says find each compound probability, state whether the events are mutually exclusive or not mutually exclusive, and then round each answer to 3 decimal places. So they like 3 decimal places. So on number 31. What?
So do I. What am I doing?
On number 31.
31, all right. Can I read it?
Sure.
Marina is checking parking stickers in a parking lot where 54 vehicles are parked. There are 38 cars, 11 trucks, 4 motorcycles, and 1 motor home. Or motor home. 1 motor home.
Okay. All right. So there's 54 total. 38 of them are cars, 11 are trucks, 4 are motorcycles, and 1's a motorhome or an RV. Okay. So for part A, it says she checks a motorcycle or a car. So can it be both a motorcycle and a car at the same time?
No.
No, 2 totally different things. She checks a motorcycle or she checks a car. So what's the probability of checking a cycle or a car? How many are motorcycles?
4.
So you got 4 out of the 54 are motorcycles. How many are cars?
38.
So 38 out of 54 are cars. 4 were motorcycles. There were 38 cars. So you're basically adding those together to get whether it was a motorcycle or a car. So 4 plus 38.
42.
So I got 42 over 54. Can I simplify that?
Yeah. So 79.
7 ninths, right?
Yeah.
So what is that as a decimal?
7
With 7 repeating, but it said round to the nearest 3 decimal places, so it's 0.778.
0.778.
And we said they were mutually exclusive, because can it be one and the other at the same time?
No.
No. Okay. So that was number, whatever, 31, right?
31, part A.
Okay. That's part A. So now we still got to do part B. Part B. Part B says she checks a motorcycle or a truck. So is it the same thing, or two totally different things? Yes?
Two totally different things.
Okay. Probability of a cycle or a truck. Right? Motorcycles, yep. There were still 4 of those. Trucks, there were 11, correct?
Mm-hmm.
So 4 plus 11.
It's 15.
15 over 4.
That reduces down to 5 over 18.
Okay.
5 divided by 18. 18. That equals 0.278.
And we said it was also
mutually exclusive.
Part C. Part C says she checks a truck, a motorhome, or a car. So the probability of picking the truck, probability of checking the motorhome, which I'm just calling it RV because that's a lot shorter to write, or probability of checking a car. So truck, RV, or car. So this time, instead of having 2 fractions added together, we're going to have how many?
3.
3. The truck was 11 over 54. The RV was 1 over 54. And the car was 38 over 54. So we add those 3 fractions together. So when we add all that up, we get what, 50 over 54?
50 over 54.
So we reduce that to
25 over 27.
Mm-hmm.
25 divided by 27 equals 0.926.
Okay, because you have 0.925 repeating, so it's 925, 925, so that 9's going to make the front of it go up to 6. Now, again, can any of those happen at the same time? Can it be a truck and a car at the same time?
No.
So these are also mutually exclusive. Okay. So everybody have all those down? Yes, no?
Yeah.
All right. Okay. We're going to skip. Oh, maybe. I can't get my page turned. We're going to skip number 32. You're going to go back and do 32 on your own. Did y'all catch that?
Yeah.
Go do 32 on your own after class is over. Right now, we're going to skip, so you got to turn the page. And we're going to do number 35. Okay? So, we're doing number 35.
Speak English.
35. It says Norman has cards that contain 1 card of each number, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we got 0, we got 1, we got 2, we got 3, we got 4. So how many cards does he have total?
10.
10 cards.
10.
Very good counting. All right.
Let's go.
He has 1 card of each, so it's got 10 cards total. Okay, so for part A says we want the probability of a 2 or an even number not including 0 will be chosen. Okay, so probability of 2 or even not 0. Okay, so on this one, is 2 also an even number?
Yes.
Yes, so it's included in that. So we have to be a little bit more careful in here. We have to subtract out what's doubled because you can't count it twice. Okay, so the way we do this is you put your probability of getting a 2 is 1 chance out of how many cards?
10.
10. Probability of evens that aren't 0 are 1, 2, 3, 4.
Or.
So there's 4 chances out of 10 that it's even, right? Yes. What's your chances of it being a 2 and even at the same time?
1.
There was one of those. So you have to subtract that one back off because you can't count it twice. Right? So basically, since the first thing and the last thing are the same, they're going to do what to each other?
Cancel.
Cancel out. So I have 4/10, right? What's 4/10 going to equal as a decimal?
0.4.
And you say these are
not mutually
exclusive.
exclusive.
Okay. Part B. Part B says the probability of an even number, or what's the next one?
Not prime.
Even or prime. Okay.
Even or prime.
Okay, so even or prime. So evens, how many evens are there?
4.
Okay. Prime numbers.
Prime.
This is prime, right?
Yeah.
This is prime?
Prime. 5 is prime.
No. Yeah, prime. Prime.
7.
Right? So how many primes are there?
4.
4. Okay. Now how many even primes are there?
1.
1. So we gotta take 1 back off. Okay. So 4 plus 4 is 8 minus 1.
Is 7.
So it's 7/10 or 0.7,
0.7.
and it's not mutually exclusive. I'm not going to keep writing that every time. Part C. Probability of getting a 6, right? I'm writing it out. Or a multiple of 3. Okay? And I still wrote the wrong thing there. Probability of a 6 or a multiple of 3. So what's your chances of getting a 6?
1 out of 10.
There's 1 out of 10. Multiples of 3. So that means 3 can go into it. So there's 3.
3.
There's
6.
6. And there's
9.
So there's 3 of those. Are any of those duplicated?
Number 6.
6 is also a multiple of 3, so I got to subtract that one back off. So what am I going to end up with?
3 out of 10.
3 out of 10.
4.3.
3.
Not mutually.
Not mutually exclusive. Do y'all agree with that or no? So what else what do you got to work on?
Speaking up.
Which one? No. What are you talking about, boy? What problem did I skip that y'all got to do?
Number 32.
Number 32 and
Number 36.
34. I want y'all to try 32 and 34.
34. Okay.
Okay. So 32 is more like 31. 34 is going to be not 34. What is it?
36.
36, yeah.
Let's go.
Mercy. All right. So whichever ones that we skipped that I told you to do.
All right.
Just do until problems, okay? So there's two. The one right after we did 31. So you do 32 and then 36. 32 should be like 31. 36 should be like 35. Okay? And tomorrow we'll check those, do the last two, and then we'll talk about probability of multiple events.
All right.
Yay.
All right, Miss Bell.
Don't forget to do this problem.
Okay.